Hello everyone. So in this video we will discuss about vapor compression refrigeration system components, and in this video we will discuss about classification and working of compressors. So basically compressors are used in many applications, but today we will discuss the compressors in the context of refrigeration purpose. So this video will be in two parts. In the first part we are discussing about the introduction, basic terms, and the reciprocating compressors, and in the second part we will discuss about the centrifugal compressor and the performance characteristics. So first of all, let's have some introduction about the compressors. So a refrigerant compressor, as the name indicates, is a machine used to compress the vapor refrigerant from evaporator and to raise its pressure so that corresponding saturation temperature is higher than that of the cooling medium. It simply means compressor is a device or a machine which is generally used to increase the pressure of a refrigerant, that is from low pressure to a higher pressure, so that the saturation temperature is higher than that of the cooling medium. It also continually circulates the refrigerant through the refrigerating system. So it helps to circulate the refrigerant in the entire refrigerating system. Since the compression of refrigerant requires some work to be done, so as you know that if we want to compress the refrigerant, we have to do some external work, and this external work will be supplied by the prime mover, or we can say a motor. What is the classification of compressor? Classification of compressor is mainly broadly classified in many ways. So we will have some different ways in which we can classify the compressors. The first method of classification is according to the method of compression. The main parts of this classification are reciprocating compressor, rotary compressor, and centrifugal compressor. The second way of classification is according to the number of working strokes. So we can have single acting compressor and double acting compressor. The third way is according to the number of stages. So we can have a single stage compressor or a multi-stage compressor. A single stage compressor is generally used where the pressure ratio requirement is less, but a multi-stage compressor is used where we need higher amount of pressure ratio. According to the method of drive employed, we can have in this way we can have direct drive compressors and belt drive compressors. So according to the location of the prime mover, that is the motor, the location of the motor, we have two methods of classification, that is semi-hermetic compressor, in which the motor and compressor are in the separate housings, and we can have a hermetic compressor where the motor and compressor are in the same housing. So that was about the classification. Now comes to the important terms. The following important terms which will be frequently used. First one will be suction pressure. As you know that when we start compressing, we need the refrigerant to be sucked into the compressor, and at what pressure the refrigerant is sucked into the compressor is known as suction pressure. So it is the absolute pressure of the refrigerant at the inlet of a compressor. Similarly, we can have a discharge pressure, that is after compressing the refrigerant, we need to discharge that refrigerant to the evaporator or a condenser. So the absolute pressure of the refrigerant at the outlet of the compressor is the discharge pressure. Third one will be compression ratio, or we can say that it is a pressure ratio. It is a ratio of the absolute discharge pressure to the suction pressure. So we just divide the discharge pressure to the suction pressure, and then we can get the pressure ratio. The pressure ratio is always greater than 1, greater than unity. Fourth one is suction volume. It is the volume of the refrigerant sucked by the compressor during its suction stroke. So when the suction happens, the volume of the refrigerant which is sucked by the compressor is known as its suction volume. Fifth one is piston displacement volume or stroke volume or swept volume. So we can say that when the piston moves from top dead center to bottom dead center, the amount of the volume swept by the piston is called the swept volume. So it is the volume swept by the piston when it moves from its top dead center to the bottom dead center. So basically its formula is pi by 4 d square L which is the formula of a volume of a cylinder. So where D is the diameter of the cylinder and L is the piston stroke, length of the piston stroke. Seventh part is compressor capacity. It is the volume of the actual amount of the refrigerant passing through the compressor in a unit time. So we can say in 1 second how much volume of the refrigerant is passing through the compressor. That is represented as compressor capacity. Its unit is cubic meter per second. Eighth one is volumetric efficiency. So it is the ratio of the compressor capacity or the suction volume to the piston displacement volume. So we can say volumetric efficiency is suction volume over piston displacement volume. So that was all about the important terms. Now today we are going to discuss about reciprocating compressors. This is the diagram of 4 stages or 4 strokes of a reciprocating compressor. That is, the suction happens, then the compression happens, and then the discharge happens. So let's see how it goes. So the compressor in which the vapor refrigerant is compressed by the reciprocating, that is back and forth motion of the piston, are called reciprocating compressors. So in reciprocating compressor, the piston moves back and forth, up and down. So in a reciprocating motion, the compressor is going to compress the refrigerant. So this is called reciprocating compressors. These compressors are used for refrigerants which has comparatively low volume. So where the refrigerant volume is less and differential pressure is high, the pressure ratio is high, it is generally used the reciprocating compressors, generally as ammonia, R12, R22, methyl chloride are the refrigerants where we use reciprocating compressors. Reciprocating compressors are available in sizes as small as 1 by 12 kilowatt, which are used in small domestic refrigerators, and up to about 150 kilowatt for a large capacity installations. So this is the size range of the reciprocating compressors. The two types of reciprocating compressors in general use are single acting vertical compressors and double acting horizontal compressors. So as we have discussed the two types of single acting and double acting compressors, the single acting are generally vertical compressors and double acting are horizontal compressors. The single acting compressors usually have their cylinders arranged vertically, radially in a V or W form. So this is the arrangement for single acting compressors where the cylinders are arranged vertically, radially in a V form or W form. The double acting compressors usually have their cylinders arranged horizontally. Figure shows a single stage single acting reciprocating compressor in its simplest form. So that was the figure that I have shown is a single stage single acting vertical reciprocating compressor in its simplest form. So you can see in this diagram there is cylinder head, there is a discharge position, suction, we have a suction valve, we have a discharge valve, we have cylinder, and we have connecting rod, and then crank, and then we have piston. So these are some motions shown here. As the piston moves from top dead center to the bottom dead center, the black arrow shows that the refrigerant is going to suck into the volume of the cylinder. So as the piston moves downwards, the entire volume of the refrigerant is present in the cylinder. As the piston moves from bottom to up, that is from bottom dead center to top dead center, then the compression will happen, and after the compression there is a discharge. So let's see the process in detail. So let us consider that piston is at the top of its stroke. So first of all we consider that the piston is at the top position. Thus is called the top dead center position. So it is we can say it is a top dead center position. In this position, suction valve is held closed because of the pressure in the clearance space between the top of the piston and the cylinder head. So at the first position, the suction valve is also closed because there is some gas, there is some pressure between the top dead center position of the piston and the cylinder head. The residual refrigerant is already there. The discharge valve is also held closed because of the cylinder head pressure acting on the top of it. So discharge valve is the first position is also closed. So when the piston moves downwards, so when the piston moves from top dead center to bottom dead center during suction stroke, the refrigerant left in the clearance space expands. So the refrigerant which was also already there is going to get expand into that space. Thus, the volume of the cylinder above the piston increases and the pressure inside the cylinder decreases. So when the piston goes down, the volume of the cylinder increases and the pressure inside the cylinder decreases. When the pressure becomes slightly less than the suction pressure or atmospheric pressure, the suction valve gets opened and the vapor refrigerant flows into the cylinder. So as the pressure drops, the suction valve gets opened up and the refrigerant is going to suck into the cylinder. This flow continues until the piston reaches the bottom of its stroke. At the bottom of the stroke, the suction valve closes because of the spring action. So as the piston moves from the top dead center to the bottom dead center, after the suction process has been completed, the suction valve gets closed because of some spring arrangement. Now when the piston moves upward during compression stroke, the volume of the cylinder decreases and pressure inside the cylinder increases. So when the piston moves from the bottom dead center to the top dead center, the cylinder volume decreases and pressure inside the cylinder increases. When the pressure inside the cylinder becomes greater than that on the top of the discharge valve gets opened and the vapor refrigerant is discharged into the condenser. After the compression process, the discharge valve is opened up and the refrigerant is going to discharge into the condenser and the cycle will be repeated. It may be noted that in a single-acting reciprocating compressor, the suction, compression, and discharge of the refrigerant takes place in two strokes of the piston. So we have just two strokes of the piston, that is from top to bottom and bottom to top, and one revolution of the crankshaft. So we have some important points for this discussion. First one is in a double-acting reciprocating compressor, suction and compression takes place in both sides of the piston. So as you know that if the piston is of double acting type, then the suction and compression will happen on the both sides of the piston. It is thus obvious that such a compressor will supply double volume of the refrigerant than a single acting reciprocating compressor. So the double acting cylinder has a benefit that it supplies double the volume of the refrigerant than the single acting reciprocating compressors. There must be a certain distance between the top of the piston and the cylinder head when the piston is on the top dead center so that the piston does not strike the cylinder head. So as we have discussed, there is some space given between the top of the piston and the piston cylinder head, that is clearance space, so that the piston does not strike the cylinder head. The distance is called clearance space and the volume therein is called clearance volume. Refrigerant left in this space is at discharge pressure and its pressure must be reduced below that of suction pressure before any vapor refrigerant flows into the cylinder. So the refrigerant that is left in that space at the discharge pressure, it must be reduced, its pressure must be reduced to the suction pressure before the refrigerant flows into the cylinder. The clearance space should be minimum. So the low capacity compressors are air cooled. The cylinder of these compressors generally have fins to provide better cooling. If the compressor is of low capacity, compressor is of less size, then it is generally air cooled and we provide fins for air cooling. The high capacity compressors are cooled by providing water jackets around the cylinder. So the high capacity compressors are water jacket are provided and it is water cooled. So this is all about this video, and we have discussed the working of reciprocating compressors, we have discussed some important terms, and we have discussed the classification of the compressors and the introduction part. So that's it from today. We will discuss the part 2 in the upcoming video. Thank you very much.